So I rewrote the same problem. I think I rewrote this same problem, and what I'd like to do is I'd like to use a technique called we're going to use matrices. Okay, we're going to use matrices to solve this problem, and this particular technique you'll find in a textbook. The textbook will call this the Cramers Technique. All right, so let's do the best we can to solve for x. Solve for x. We're going to solve for y, and we're going to solve for z, x, y, and z, using matrices. And I will admit to you where we're about to, if you're not familiar with matrices, this will seem very, very complicated. But for the people who have worked with matrices before, this won't be too bad. All right, so what we're going to do in solving for x, y, and z is the denominators for the answers. The denominators for the answers will come from a matrix created by this part of your problem here. So we're going to have two, we're going to use the coefficients in front of each of these variables, 2, 1, and 2. And then we get 4, 3, and 4. All right, so 4, 3, and 4. Use the coefficients in front of the y. And now we'll use the coefficients in front of the z, 5, 3, and 4. All right, so what we're going to do is we are going to find what's called the determinant of this matrix. And to do that, what we're going to do is we're going to rewrite these two columns right after this third column here. So we get 2, 1, 2, and 4, 3, 4. I just rewrote those columns. And what we're going to do is just a lot of multiplying, finding something called a determinant. All right, so we're going to find the product of 3 diagonals here and subtract the product of 3 diagonals that way. All right, so what we end up with is 2 times 3, which is 6, times 4, which is 24. We just found the product of that diagonal. I'm going to take this very slowly because, man, I was studying before I got to the show, and it's very, very easy to make silly mistakes. So we'll do the best we can to take our time. Find this product. We get 4 times 3, which is 12, times 2, which is 24. Add 24. And here we get 5 times 1, which is 5 times 4, and you end up with positive 20. Now what we're going to do is we're going to subtract the sum of a bunch of products in this other direction here. You always use this main diagonal. Start with this main diagonal, and from left to right, you'll travel down. All right, so now 5 times 3 is 15, times 2 is 30. And now we have 4 times 3 is 12, times 2 plus 24. And 4 times 1, which is 4, times 4, which is 16. All right, so this is the result of this is called a determinant. So we get 48 plus 20, 68. 48 plus 20 is 68. Minus, and we end up with 24 plus 16, that's 40, plus 30, that is 70. All right, so 68 minus 70, you end up with a negative 2. You end up a determinant of negative 2, and that negative 2, that negative 2 is going to represent the denominator of each of your answers. So this first determinant, which came from this part of your problem, is going to represent the denominator of all of your answers. All right, so I put negative 2 here, here, and here. So now what we're going to do is now we're going to determine the numerator of this x value of your solution. The way you do that is you substitute this column 5, 2, 2 into the x column of your matrix. All right, so let's do that. So instead of 2, 1, 2, you're going to substitute 5, 2, 2, which came from here. into your X column of your matrix, and then you're going to rewrite everything else. So we get 4, 3, 4, and then we got 5, 3, 4. Okay? So we're going to find the determinant of that, and it's going to represent the numerator of the X value of your solution. So let's take these two columns, let's take these same two columns and rewrite them again. 5, 2, 2, 4, 3, 4, and let's find the determinant of this. A lot of multiplying this way, from left to right, traveling down, and then a lot of multiplying the other way. All right, so now what we got is 12 times 5, which is 60. 4 times 3 is 12 times 5, which is 60. And we've got 12 times 2, that is plus 24. And now we have 10 times 4, which is 40, plus 40. And now we're going to subtract a bunch of other products. So we get 6 times 5. 2 times 3 is 6 times 5, which is 30. 4 times 3 is 12. Times 5 is 60. And 4 times 2 is 8. Times 4 is 32. All right. So you end up with 60 times 40 is 100. You get 124 minus, you get 90 times 90 plus 32 is 122. 122. And you end up with a determinant of 2. All right, so that's going to represent the numerator of your answer for X. And you end up with negative 1. Negative 1. All right, so it's sort of a long, tedious process, but we'll continue on. So let's solve for the numerator for Y. Solve for the numerator for Y. So we get 2. All right, so to get the numerator for Y, we're going to take 5, 2, 2 and replace 5, 2, 2 into the Y columns, into the columns for Y. When we were solving for X, we put 5, 2, 2 into the X column. But when we want the solution to the numerator for Y, we're going to put 5, 2, 2 into the Y column. All right, so let's do that. So we'll keep this part of our matrix the same. So we get 2, 1. Uh-oh, you can't see that. Sorry about that. So we get 2, 1, 2, which was the original matrix, 2, 1, 2. And now we're going to put this 5, 2, 2 into the Y column. 5, 2, 2. And then we're going to keep this part of our matrix the same. 5, 3, 4. All right. And then we're going to find the determinant of this. All right, so we're going to find the determinant. Let's do that. We get 2, 1, 2. I'm rewriting this column here, and then I'm rewriting this column here, 5, 2, 2. And I'm going to find the determinant of this. And again, this is going to represent the numerator for our value for Y. Let's find the determinant. We get 4 times 4, which is 16. 2 times 2 is 4, times another 4 is 16. Plus 15 times 2 is 30. And then 5 times 1 is 5. Times 2 is 10, plus 10. And I'm going to subtract. All right, let's find this product. We get 2 times 2 is 4. Times 5 is 20. 2 times 3 is 6. Times 2 is 12. And 4 times 1 is 4, times 5 is 20. All right, so let's figure this out. We get 40 plus 16, that's 56, minus, we get 40 plus 12 is 52. 56 minus 52 is 4, so that's going to represent the numerator of our solution for y, and you end up with a negative 2. End up with a negative 2. I'm going to rewrite this original matrix that I had here, but instead of 5, 3, 4, I'm going to substitute in 5, 2, 2. All right, so let's do that right now. All right, so we got 2, 1, 2. We got 2, 1, 2. And then we had 4, 3, 4. 4, 3, 4 came from this initial matrix. We got 4, 3, 4. And now in the Z column, I'm going to replace 5, 3, 4 with 5, 2, 2. 5, 2, 2. And now what I'd like to do is we have found the determinant. We found the determinant by rewriting these two columns here and here over on the right side there. I'd like to use mastery level understanding for finding the determinant in a technique that's not as common. Not as common. All right, so what I'd like to do is take this initial number here and cross out, act as though you're crossing out this row and this column, and you're ending up with a 2 by 2 matrix here. All right, so you're going to take this 2 and find the determinant of this leftover 2 by 2 matrix, which would be 3, 2, 4, 2. All right, and then what I'd like you to do is do the same thing. Do the same thing with this 4. All right, eliminate the row here that would be included in that 4 and the column. And here, just by rule, you put a minus sign there, minus that 4, and you'd find the determinant of this leftover matrix, which would be 1. This 1 here, this 2 here. If you're canceling out this column, this row, you'd have a 1 here, 2 here, and then a 2 here, 2 there. All right, you're going to find the determinant of that. Plus, by rule, you would have this 5. And then you would eliminate this, the column here that would include this 5, this row here that would include that 5. The leftover matrix would be 1, 3, 2, 4. All right. So it's a little bit different from the way we found the determinant before. But whether you do it this way, whether you do it this way, or if you rewrite the two columns like we've done previously, you should end up with the exact same determinant. All right. So we're going to take 2. And multiply that to the determinant here, similar to when you've got a 3 by 3 matrix where you multiply. You started with this main diagonal. We're going to do the same thing with a 2 by 2. So you get 6 minus 8. 3 times 2 is 6. Minus 2 times 4, 8. You get a negative 2. The determinant of this 2 by 2 matrix is a negative 2. Minus 4 times the determinant of this 2 by 2 matrix. You take this product, which is 2, minus 4, you get a negative 2. 1 times 2 is 2, minus 2 times 2 is 4. 2 minus 4 is a negative 2, plus 5 times this determinant, which would be 1 times 4 is 4, minus 6 is a negative 2. All right, so you end up with negative 4 plus 8 minus 10. Sorry about that. Minus 10, and you end up with 4 minus 10, which is a determinant of negative 6. So you'd end up putting a negative 6 here for Z, and then your final answer there would be 3. Final answer there would be 3. So notice how we got the solution negative 1, negative 2, and 3. Negative 1, negative 2, 3. All right, and notice how we did this same problem. We did this problem earlier, and we got negative 1, negative 2, 3. All right, so that's mastery level. That's mastery level